PLM.
Good afternoon. My name is Ben Weisenberger. I'm an application engineer with PLM Solutions. I want to welcome you to the PLM LunchByte series. Today we're going to be taking a look at working with imported geometry inside of Solid Edge. For today's agenda, we'll take a look at some of the effects of low-quality geometry. We'll also look at how to recognize the signs of poorly constructed geometry and some of the tools that we can use to improve that quality of our models. Next, we'll open up some of the files from some other CAD packages and other non-native Solid Edge formats and see how we can work with them using synchronous technology. Finally, we'll take a look at using some of the recognized commands inside of Solid Edge, how they can help us edit our imported files, and also how to apply relationships to some imported assemblies. So let's go ahead and get started. So first thing we're going to talk about is the effects of some low quality geometry. You've probably dealt with this before if you've ever imported files, some Windows display performance issues. What it really does is it slows down our Windows updates such as zoom or fit. Rotating the model can be slow or jerky at times, and you also may have some abnormal display problems such as missing faces. There's also modeling problems that you might run into, whether that be adding or removing material such as cuts or protrusions. You may deal with some direct modeling failures, unable to move faces if you're using either synchronous steering wheel or the move face command in ordered. And occasionally you may run into the problem of Solid Edge crashing or strange things happening when you're trying to finish a command. When you take your model into the draft environment and you're trying to create drawing views, you may not be able to create those drawing views. Again, you may run into some crashing issues. When you're updating your views, sometimes that fails or hangs up or takes a really long time to finish. So a lot of adverse effects here from low quality geometry. A couple ways we can identify that low quality geometry and help us improve it is the optimize command and also the geometry inspector. With the optimize command, we can increase the precision and quality of our models by simplifying the B-surface definitions. We can heal edges, and it also identifies and replaces blend-like faces with an actual rolling ball blend. The geometry inspector will inspect our model, and it will display error conditions and the associated geometry. This also gives us a repair tool that we can use then to heal the surface topology. The optimize command, it helps emphasize or displays our inaccurate edges. It also provides the options to clean, simplify, set precision, and replace blend-like surfaces. When you select a body, you can then find and emphasize the faces and edges that are problematic. There's an option on the command bar to turn on tolerant edges. This will display the tolerance, the edges with tolerance in red on your model. If you have any B surfaces that are not recognized as blends, they'll be displayed in your model as yellow. Inside the optimize options, there's a couple options we can turn on and off. The clean body option, what it's going to do for us is repair topology definitions such as degenerate geometry, any loop inconsistencies, and edges that don't lie on the surface. There's a couple pictures here that you'll see of some edge conditions and how the clean body command will repair those. If we have curves intersecting at a point, not at the end point, it'll trim those to meet. If we have two coincident curves, it'll remove one of them and modify it to meet at the corner. If there's a gap between some of our curves, it can also extend them to meet each other and close that gap. The other two options in our optimize options window is the full body optimization or simplified body only. With full body optimization, this resolves B surfaces and makes them analytic geometries. They're also trimmed to the parameter box of the face. Any sort of half cylinders that share an axis, they're merged together to create one single cylinder. We can also optimize our edges to resolve those tolerance issues that get highlighted earlier when we turn the option on the command bar, and we can also convert those B surfaces to actual blends so that we can edit them. With the simplify body only option, the only difference is the conversion of the B surfaces to the blends. That doesn't happen. We simplify everything else, but we don't convert the blends. We also have a command called Geometry Inspector. This is going to find and identify areas on our model that don't conform to the parasolid structure or guidelines, such as the following. If we have self-intersection of curve or surfaces, those will be highlighted in Geometry Inspector. Any sort of face-to-face inconsistencies, so that faces that are touching each other. If we have degenerate geometry, so zero-length curves, those will show up. Any sort of loop inconsistencies. What this also gives us is a repair tool to help resolve those topology issues, same as the optimize clean that we saw. In some cases, we may not be able to resolve those issues using the Geometry Inspector or optimize. So it'd be things like self-intersecting surfaces, face-to-face inconsistencies, or poorly defined surface definitions. So to resolve those cases, we can just do some simple surface modeling to replace faces and fix the issues. An example of what we could do, in the picture in the bottom left, we've got some issues. What we can do then is copy the body using the copy surfacing command. We then hide our actual design body. We'll delete the intersecting surfaces. As you can see in the middle, we've deleted them out. We can then create, in this case, 3 different swept surfaces. We'll stitch those 3 surfaces together, add in a bounded surface, and we can stitch the bounded surface in there as well, and then that'll fill in the geometry and make it a solid model. Another example is we can use a key point curve. Just like before, we'll copy the body using the surfacing copy command. We'll delete the overlapping faces, which we see in the first picture. Then we can place a key point curve using the tangent continuous endpoint option. As you can see, the black line in our right picture is our key point curve. Then we can draw on a couple bounded surfaces. I've got one on the top and bottom, stitch them together, and that takes care of our issues on that part. Another option we have is to use guide curves and a bounded surface. So just like before, we'll copy the body. We can place the key point curve in with the tangent continuous options, and again do a bounded surface, but this time use the key point curves as our guide curves. Then we'll simply stitch together and create a solid body from that. So I've got a couple examples we can take a look at inside of Solid Edge. So let's switch over there and open up our first example. For our first example, what we're going to take a look at is simplifying a body and what that does for us. So we're going to open up an example here real quick. I've already got this translated into the synchronous part environment, and if we were to try to make edits to some of the holes right now, you'll notice they're not actually cylindrical cutouts. You'll see they're split in half, 2 half cylinders. When I click on it, I don't get an edit definition handle, I don't get a diameter value that I can click on and edit to make a change. So what we can do is we can run the optimize command, and Solid Edge is going to give you kind of some information that you should run it. If you hold your cursor over the part here, you see the quality of this body may be improved by the optimize command. You also get this little symbol next to the part copy, just indicating that you could improve the quality of it to make it easier to edit. So we're going to go under the Inspect tab and run the Optimize command. On the command bar, this is our option to turn on our tolerant edges and B-spline surfaces. So when we turn that on, you can see we get a lot of red and yellow on here. So the red edges are our tolerant edges, and the yellow surfaces are those B-spline surfaces that we want to turn into nice blends or cylindrical holes in our case. So what we're going to do in the options is we're just going to do a full body optimization. We're going to clean up everything, do a clean body. We'll hit OK and finish. It's going to optimize the body. You can see here we've turned all of our curves into nice lines, circles, and ellipses. We've also minimized that and simplified it. We've also taken the B surfaces and made them into planes and cylinders. So now when we hit OK, our symbol's gone next to the part copy, and you'll notice all of our holes are cylindrical cutouts. We can now select. I get a diameter value, and I can edit that hole and make it in bigger and smaller. So that's what our optimize command does for us. It just, again, helps clean up the geometry and makes it easier to work with. Let's go ahead and take a look at another example here. So we're going to close out of this part. I've got another part file. Now this one I brought in from an IGES file. I've already done a little bit of work to it, but we need to do some more work. It's just surfaces right now. If we go under the surfacing tab, we have an option to go in and show non-stitch edges on the part file. So I'm going to select the part, and you can see highlighted in green here are all of our non-stitch edges. So we've got some issues with the geometry, issues with some of the surfaces. They're not fully connected, so what we need to do is do some of that surface work we talked about in the last couple slides. Now you can see over here I've done a little bit already. We've got a couple gray surfaces over on the right. I've already deleted those and bounded them in and created new surfaces. We need to do the same thing here where I've got a big void where I already actually deleted the surface. We're going to create another one in there, and then we have to edit our corner condition here of our blends. So under the surfacing tab, I'm just going to choose the bounded option. We're going to select then the edges that make up that hole that we've deleted or that surface in there. So I'm just going to pick all of those edges. We create a nice bounded surface. I can accept and finish that. I'm going to come over here and do the same thing. So I actually want to delete this corner first. So I'm just going to select that surface and delete it. We'll do another bounded surface. And again, just select our boundaries. Accept and finish, and then we can stitch it all together. So I can select the two I created and then the overall body, stitch it all together, and there we go. Now if we run the show non-stitch edges and I highlight this, you can see there's nothing left, so we fixed all of those edges. I can then just do a right click and attach. It's going to ask me if I want to add the faces to the model. I want to add them. Now we've made this a solid body, and just to prove that to you, you can go in and set our plane here and kind of cut through the model, and you can see that it is solid. So that's how we can go in with the surfacing tools, quickly make some changes to the imported geometry, create some new bounded surfaces if we need to. We could have drawn some key point curves in there to help with the curve control. But again, just a quick way to go in, make some edits, and again, if you're working with some really complex geometry or some really poor, bad quality geometry, you'll have to do this. So you should become familiar with the surfacing tools so you know what you're doing. I want to take a look at another example. I actually did this in my tip of the week one week, but I want to show you it again here. Just a good tip that we can do to also edit and delete some geometry on the model. What I want to do is delete the rounds in this corner here. You see they don't come in nicely. If I select a couple of them and hit delete, they could not be deleted because we cannot solve that corner condition and what would happen if we deleted all of those. So what we can do is I'm just going to place a plane in here and then use that to draw a sphere. So with the new quick create shapes in ST7 and 8, I can do a sphere, and I'm just going to draw a ball here, or a sphere, that covers that entire corner. I can now select those same rounds that I wanted to delete, and I should be able to hit delete, get rid of them without any issues, and then simply just delete that sphere I created, and you can see it solves that corner, and we don't have to worry about that anymore. So again, just a nice tip, how to use other geometry, use those quick create shapes to help edit poor corner conditions like that, and help make it easier to delete the geometry and get the corner conditions that we want. Alright, let's take a look at another example. This one we're going to work with importing some other geometry from other CAD packages. So we're going to open up another example. I've got a frame assembly here. We're going to bring in some parts, one from another CAD package, one's a Parasolid file, and then also a DWG. So let's start with a part from another CAD package. So I'm simply just going to go up to Open, and you see here I'm going to open up a part. That's not a native Solid Edge file. If I go here, these are all the other types of files that we can import or open right inside of Solid Edge. We can do things like Parasolid Step, JT, IGES. We can open up then directly from other CAD packages. So in this case, we're going to open up from another CAD package. I'm going to select the file and hit Open, and I'm going to open it up into a Solid Edge part environment. And just like that, we brought it into Solid Edge. I'm going to apply maybe a different color so it's a little easier to see. We're going to make this orange. And with synchronous, we can start editing the part directly. So I can select one of the faces, grab the steering wheel, and start to push and pull that. And you see with our design intent and live rules, it picks up the other faces and allows me to make changes to the entire model. I can select one of our holes. Maybe I want to change the diameter of this. I'd make the hole larger or smaller. Maybe I want to make that 7 millimeters. We can also drive the model with smart dimensions. So I'm going to apply a dimension between our top two edges up here. And I want to make this flange larger. So I could increase that, or I can make it smaller, and maybe I want to make that 6 millimeters. So not only can we use the steering wheel to push and pull faces, we can also apply dimensions directly to the model. You'll notice here in our corners, we've got a couple different corner conditions. We've got a nice round in this corner, but it's not so pretty in this corner. Maybe the engineer did it in a different order. We weren't the ones to create it, but we need to edit this. If we were to try to edit it right now, it would not edit correctly, so we need to make a change to that corner. In Solid Edge, it's pretty easy. All we have to do is right click on that and choose Reorder Rounds. It's going to change the way that that corner is calculated into the correct condition that we want. We can also do the same thing over here. Right click, Reorder Rounds. Now we can choose the rounds, grab the Edit Definition handle, and edit them all at one time if we want, and make our rounds bigger. We also have the ability to delete faces, so I can just fence select whatever I want. In this case, maybe I want all of those little faces down in each pocket and just delete them. So I'm going to highlight them, hit delete on my keyboard, and get rid of those. Another option that we have, which I'll talk more about in another example, is recognize holes. We can add some intelligence into the model. And I want to recognize these four holes and actually make them counterbore holes. Right now they're simple, so I can switch to counterbore, pick what size I want, and hit OK. And now you can see it's switched all four of them to counterbore holes. And just to show off a little, we can grab one of those holes, and with the steering wheel and the design intent, we can move around and make any sort of change that we want. Let's go ahead and save this part. We're going to use this in our assembly. So I'm going to save that and close out of it. And we're going to place this over here into our assembly. So I'll bring that part in. We'll apply a couple assembly relationships. I'm just going to place it on here for right now. We're going to place another part in just a minute, so we're not going to fully constrain this one yet. I'm just going to scoot it over close to where we want it. Now the next file we're going to open up is a Parasolid file. So I'm going to browse out here and find a Parasolid document, and this is a sheet metal file. So I'm going to open this one up into the sheet metal environment. Now again, this one comes in kind of as a dumb solid, just a part copy, so we don't have any sort of history. With this part, we also have the DWG and all of the drawing dimensions applied to it. Instead of trying to recreate all of those dimensions, we can reuse them here on this model. So I'm going to save this real quick. I'm going to open up that DWG file I was just talking about. So I'm going to bring this into the draft environment. So this could be from a supplier or someone else, or this could be a legacy file, but we want to reuse this. We don't want to waste any of this data, so I'm simply going to reuse this using the create 3D command. Now you've probably seen this before. where we've added it to a new file and created a part from scratch from it. But what we can also do is add it to an existing file. So I'm going to add it to that file, the sheet metal file I just opened up. I'm going to select the geometry that I want, or the drawing views here, and it's also going to bring over these dimensions. So when I hit finish, you'll see it brings those sketches into that sheet metal part environment with all of the dimension information. I'm going to move the sketches over so they're centered up on my part, and let me move it down so it's on top of it. And then all I have to do is a right click, attach PMI, and it attaches all of those dimensions directly onto my 3D model. So now I don't have to recreate those. I didn't waste any effort that anyone else had taken to create the dimensions. I'm simply going to use them now to make changes to my 3D model. I can drive that out, and you see with the design intent it's moving the back leg also, and I want that to be maybe 35. We need to make this wider to fit onto the rail, so I'm going to increase this to maybe 51, and just like that we've reused that existing data, or maybe it was data from someone else, and made changes to the model so it now fits our assembly. Right now this is still a part copy. Like I said before, I want this to be a sheet metal file, so we have a command called thin part sheet metal. All I have to do is run the command, pick one of the faces on my model, and it's recognized the tab and all of the flanges off of that for me automatically. I can now go into flatten and create the flat pattern from that part. If you remember, this was a parasolid file, but with synchronous and all of the tools built into Solid Edge, I can easily make this into a workable part that we now have the flat pattern for, and we could easily produce this. So we're going to use this in our assembly, so I'm going to close out of it. And our drawing, we don't need that anymore. We're going to bring that part into our assembly now. Again, we're just going to apply a couple assembly relationships to it. And there we go. Now I want to get these two parts lined up, so I'm going to do some more assembly relationships just to get the holes lined up, and also get the back face of this mated to the front face of our sheet metal part. Alright, now we need to bring in one more part. This one I've already translated in. This came in from another CAD package, but I've already got it as a part. I'm just going to drag it in just like we've done before. Apply a couple more assembly relationships. And I'm going to apply one more mate and get those lined up, and there we go. Now we can see that our two parts don't line up exactly, which is no problem with synchronous. I'm going to edit into this part file. I'm actually going to edit this though in the context of the assembly. I'm going to turn the background components back on. What we're going to do is do an extrude. I'm going to reuse the geometry of the flange of this inventor part file. I'm going to select that and extrude that out and add that to the flange of my SolidWorks part file, the orange part file. And you can see now I have matching flanges, so I could easily mount those two parts together. And just to show off a little bit here, we can also edit the parts in the context of the assembly without editing into them with our part priority options in the assembly environment. So I can select this entire part. Maybe I want to move that up 20 millimeters so we have some clearance. I could also edit two parts at one time, so I can grab both the inventor part file and the SolidWorks part file and make a change to both of them at the same time. So just like that, you can see how easy it is to import non-native Solid Edge files. We can bring in files from other CAD packages. We can also work with parasolid files and make any sort of change that we want to in the synchronous environment. The next thing I want to show you is the Recognize Patterns command, which was added in ST8. This is going to enable us to find patterns for any sort of geometry that we want. In ST7 we had Recognize Hole patterns, but now we can recognize patterns of anything. What we have to do is supply the master geometry, then Solid Edge will analyze the model to look for patterns or similar occurrences of that geometry. This works in the synchronous pattern creation in part, sheet metal, or the assembly environment. It's only going to recognize rectangular or circular patterns. but it'll support radial patterns, for example linear patterns on a cylindrical surface, as in the picture up here in the top right. We can also run this multiple times on different geometry in one part file. So in this example we've got an inner ring of slots and also an outer ring of slots, and we can run this command twice and find both patterns. So let's go ahead and take a look at the recognize patterns command inside Solid Edge, as well as some of the other recognize commands that are available to us. So we're going to open up a part file, and this is actually a parasolid file, so we're going to translate this into the part environment. The first thing I want to do is recognize some of the geometry. I want to recognize the pattern of this feature on top here. So I'm just going to select that geometry first. Under the pattern command is recognize patterns. So I'm going to run the command, and it's going to recognize that geometry again that I had selected and recognize it as a pattern. In this case, I recognize it as a circular pattern with 4 occurrences. So after we recognize the pattern, we can edit into it, and I can increase or decrease the count to increase or decrease the occurrences of that pattern, which is pretty cool. Another new command is recognize chamfers, which is underneath the round command. We simply just use this to recognize any sort of chamfer on the model. It'll add it into our Pathfinder. I can then select that chamfer from Pathfinder, or graphically we have an added definition handle, then I can select and increase or decrease the value of that chamfer. We can also recognize holes, which is one of my favorite commands, so I'm going to select the command. We've recognized one of the main holes here in that pattern feature. We have the 12 holes in the back and then the large hole through the model. What I want to do is just do a face selection. I want to pick this face and just recognize the holes on that face, which would be all 12 of them. They're simple holes. I want to change them to counterbore holes. So I'm going to change the type to counterbore. Maybe I want to make them M5. Hit OK, and there we go. Now they're recognized as smart holes. I could go in and change the type of hole at any time. Now there are 12 occurrences. Maybe I want 10 or 8, so I can also run the recognize hole patterns command. Fence select the area that contains the holes. I now have a circular pattern. I can define my master occurrence, so maybe I want this top hole to be my master occurrence, and hit OK. Now I've got a pattern of those holes. I can edit into it and change the count, maybe make it 10 or 8, and there we go. So there are some of our recognized commands inside of Solid Edge, which help make dumb imported geometry into intelligent geometry that we can easily edit and get what we need. I've got one more quick example. I've got an assembly file that I've saved down as a parasolid. I'm going to open that up into an assembly document. Now you'll notice all of these parts, when they come in, they're automatically grounded. So every single one of my part, they're grounded here. This top part is a roller, so it should be able to spin, but since it's grounded, that can't happen. So this isn't very useful when we just import the geometry, but we have an option that can help us out to apply the appropriate assembly relationships. So what I'm going to do is select my base plate and then run the assembly relationship assistant. Now what we can do is we can remove those grounded relationships from the part and then create relationships between all of the components that we are going to highlight. So I'm going to hit OK. I'm going to highlight the rest of the components in the assembly and accept it. I can pick the relationships that I want, whether they're mates, axial lines, planar lines, offsets, or connects. I'm going to stick with just mates, planar lines, and axial lines. We can process that. Here are all of the relationships that it's going to apply between the models. If there's something specifically that you don't want, maybe an axial line between bolts or something like that, you can always come in and uncheck them. I want everything here, so I'm just going to accept it and then close. Now you can see if I click on one of my parts, I have all of those assembly relationships applied to the model. So I've got some axial lines between bolts, I've got a mate between the support and the base plate, and also a mate between a couple of my bolts. Now looking at the components in the Pathfinder here, it says they're under constrained. That's because I don't have any of my components grounded anymore because I ungrounded everything. So in this case what I'm going to do is select my base plate, I'm going to ground it, and now we can see they're all fully constrained like they should be, except my roller, which I want to spin, so my rotation is unlocked, allowing that roller to spin. So that saved me a bunch of time from going in and trying to recreate all of those relationships one by one. I can just run that assembly relationship assistant and get what I need in my assembly. So that's all I had for you guys today. I appreciate your time. If you have any questions for me on this topic, or if you have any suggestions for future LunchByte topics, feel free to email me or give me a call. Once again, I appreciate your time. Thanks, and have a great day.
LIPLM